Hello and welcome everybody to this 2 p.m. live broadcast. So we're back again on a Sunday. Thank you for joining me, everybody on Patreon. For anybody who's watching a recording of this on YouTube, thank you very much for watching this as well. If you please click the subscribe button, like it, comment, but also if you can, perhaps join us on Patreon, because on Patreon we'll be doing the full video, so you'll be able to see a recording of this full video. What I mean by that is on YouTube today I'm going to be going over some theory and ideas about a particular topic, which I'll tell you about in a minute. But then when we do the Patreon, we're actually going to be doing some exam style questions as well. So you will have seen the title of the video, presumably, if you're watching a recording. So today we're doing percentages, decimals, and fractions, but specifically how we convert between them. So for the YouTube crowd, we're first of all going to be going over how we convert from each type of number from one to the other, cyclically, so how we go back and forth. And then for the Patreon viewers, either live now or as a recording, we're going to be then looking at some exam style questions afterwards. So for both of those types of people listening live or watching a recording on Patreon, there is an attached file to this video in the post that you will be able to open, and it has all the exam style questions that we'll be going over. We might not actually go over all of them together today. We may skip a few, as I feel it might be repetition perhaps. We'll see how we're going. So those questions are there for you to do on your own in your own time as well. Okay, so let's get started. So if everybody can get their notebooks ready, if that's the way you learn, I advise getting your notebooks out so that you can take notes as you go, and then you can keep track of the work you've done. We're going to make a start on, first of all, we're going to start with percentages, but we're going to write a title first. It's always good to have titles, purely so that when you look back at your work and your revision, you can see when you've done what. I always prefer writing a date as well. It's force of habit, but also, as I say, it helps you keep track. So I'm going to write percentage, decimals, and fractions conversions. Okay. And the date today is, it is the 9th today, the 9th of March. Okay, fantastic. Right, so we're going to start with percentages let's go to decimals first. Now, percentages to decimals is very simple. It's going to be very quick. We're then going to look at decimals to fractions because it will just be reversing the process. And fractions is where it gets a little bit more complicated, but we can handle it. So percentages to decimals, essentially, let's say I had 56%. The process is simply to multiply. Sorry, not multiply. We haven't started off on a good foot. We need to divide. For that, haven't got it on my keyboard. We need to divide by 100. And so there we get, as long as we know how to manipulate decimal numbers and divide by multiples of 10, we get 0.56. Okay. So presumably at this point, we all know that percentages are normally out of 100. 100% means that the full amount. We can talk in percentages above 100, but what that means is the full amount plus a bit extra. So today we're just going to be focusing primarily on numbers below 100, and thinking about percentages as parts of a whole. So 56% is 0.56. So we've divided by 100. And to divide by multiples of 10, you simply move your decimal point left or right if you're multiplying. So let's say I had the number 780 and I want to divide it by 1,000. I know that 780 has a decimal point at the end of it because any whole number has a decimal point at its end. So to divide by 1,000, which is a multiple of 10, I move the decimal point the number of zeros that I have in that number. So in 1,000 I have 3 zeros, which means I move my decimal point left 3 times. So it would go to 78, 7.8, and finally it would be 0.78. Similarly, if I'm multiplying, so say I had 65 and I multiply by 10, I move the decimal point over. So I know that 65, the decimal point, is at the end of it. So if I want to move my decimal point to the right, then what I do is I move it to the right and imagine there are an infinite number of zeros after my whole number. So it'd be 650 point. If I moved it again, it would be another 0. which is why when we multiply and divide by multiples of 10, we often speak of it in terms of dividing and multiplying. Speak of it in terms of taking off zeros or adding zeros. That's kind of what you're doing. But then when you don't have zeros involved, you need to know that you're moving that decimal point so that you can move it inwards with the digits. But the digits always stay the same. Okay. So percentages to decimals, we divide by 100. Great. So similarly then, if we want to go from, don't want it to be that big, if we want to go from decimals to percentages, we reverse the process. So let's say I have 0.23. I multiply by 100 here to get my percentage, which is 23%. So I've moved that decimal point twice to the right because I'm multiplying, and there are 2 zeros in 100. Obviously, as I mentioned before, we're using 100 because percentages are out of 100. So that's why 100 is the key number here. And we manipulate numbers back and forth by doing that. Okay, lovely. I'll just do a couple other examples. So let's say I have 45%, I have 0.51, or I have 89%. One more I will do 3%. Let's check what that is in a minute because it will be slightly different. So to get from percentages to decimals, I divide by 100. So this is going to be 0.45. To get from decimals to percentages, I multiply by 100. So this is 51%. Percentages to decimals, I divide by 100, 0.89. Now here again, we've got percentages to decimals, so we're dividing by 100. What we don't want to write, though, is 0.3, because that's lazy. People will see these, and they automatically go, okay, so I just go 0 point and then the number. But you need to be thinking, if I divide it by 100, where is the place value going to be for that 3? So if I have the number 3 and I divide it by 100, my decimal point is after it. So divide it by 10, you get 0.3. Divide it by 10 again, you get 0.03. So any single percentage will always be 0.0, the digit, and not just 0 point. Because 0.3 is actually 30%, which is obviously a completely different percentage, so we don't want to get those two mixed up. Okay, brilliant. Right, so now we've got to bring our fractions in. So initially, fractions are actually quite simple in terms of getting to the fractions from either a decimal or a percentage. So I'm actually going to write this, and we can be taking that. Make sure, I'm just going to give you a moment, actually, if you're watching live, just to get those notes written down. Just percentages to decimals, divide by 100, decimals to percentages, times by 100, and then we will move on. So I'm just going to give you a minute now to get that written down. Okay, cool. Right, so we're going to go from percentages / decimals, fractions. Because I feel the conversion between decimals and percentages is quite easy and it's quite quick, we can look at both of these maneuvers at the same time. So let's say I want to have 76% as a fraction. Now, first of all, it could be 0.76. That would be its decimal conversion. So we'll look at how we get from either of these numbers to fractions. So the number after the decimal point, or indeed the number before the percentage sign, is out of 100, right? So logically, it makes sense to turn this into a fraction. It's going to be 76 over 100. Okay. Obviously, we would normally write fractions a little different to that. I'm doing it on the computer today, so you could have written it like that there. Okay. Now, that's fine. There's nothing wrong with that answer. That's perfect. If the question, though, says simplify the answer or write it in its simplest form, we need to be able to simplify these fractions. So that might be something you're already familiar with, but let's briefly go over that again just in case. So with fractions, when we want to simplify them, what we're looking for are common factors between the numerator, which is the number on top, and the denominator, which is the number underneath. So we don't necessarily have to find the highest common factor to begin with, although we can do, and that would be the shortcut way to get to your final answer. But if you can just spot any factor, then you can just divide by that number and then keep going until you get to your simplest fraction. So whenever you see two even numbers, you know that they both have a factor of 2. So we're just going to do that for the time being. So 76 divided by 2, we won't waste too much time calculating it, but that will give us 38. And then 100 divided by 2 is 50. Now again, they're both even, so I can do the same process again. So 38 divided by 2 is 19, and 50 divided by 2 is 25. So 19 is prime, so we can't go any further than that. 19/25 would be our final answer as a fraction of 76%. Okay, let's do another one. Let's say I have 42%. We're going to make that a little bit bigger. Do it down here. So 42% as a fraction will be 42 over 100. Now, if I'm going to simplify that, again, I can divide by 2. So 21 over 50. Now, neither of them are prime. That's not relevant, but they don't have any factors in common. So 21/50 is the simplest version of that fraction. Okay, so what I'm going to do now is I'm going to give you some various percentages or decimals. I want you to convert them to fractions and also simplify them. Okay, so I'm going to give you a few minutes to do that. We're going to do 5 of those questions, and then we'll come back and go over the answers together. So have 1, which isn't letting me do. Okay, 1, 36%. 2, 0.28%. 0.28. 3, we'll just do 3 for the time being, and then I'll touch on something else. 61%. Okay, right, I'm going to give you a few minutes just to do that, and then I will be back. Okay, well done. So hopefully we go through the answers. We would have had 36 over 100, which simplifies down to 18 over 50, which simplifies down to 9 over 25, which is great. And then here we'd have 28 over 100, which simplifies down to 14 over 50, which simplifies down to 7 over 25. And finally, 61 over 100 is as it is. It won't go any further than that. Okay, something else I want to touch on is if you have a percentage that isn't just a 2-digit number. So let's say we had 8%, or indeed 0.08, that's the same. Now, that's 8 out of 100. So that would be exactly the same there. So we'd put 8 over 100, which would be the same as 4 over 50, which would be the same as 2 over 25. Okay, But if our numbers start to have decimal numbers, that's where it gets a little bit more confusing. So let's say I had 52.3%. Okay, so 52.3% means that this time I have to count the number of digits in my percentage, and that will tell me the number of zeros that are going to be in my denominator underneath. So yes, we do percentages out of 100, so it's 52.3 out of 100, of course, but it'll be 523 out of 1,000. We think about the logic of that. That would be 52.3 over 100. Now, we can't actually have that. We can't have a decimal within a fraction, so we can't have the numerator or the denominator having decimals in it as a fraction. So what we need to do is multiply the numerator and the denominator by 10 to make them both integers, whole numbers, which brings us to 520 over 1,000. So if you have a decimal that's 0.2986, you count the number of digits, that will tell you the number of zeros under the fraction. It's 4. So it'd be 2,986 over 10,000. So there's a slight difference there. If you've got decimals, you just count the number of digits. That tells you how many zeros are going to be underneath our multiple of 10 or multiple of 100 underneath in the denominator. Okay, cool. Right, now we're going to have a look at fractions I'm going to put decimals, percentages. I'm kind of pushing them together here, decimals and percentages, because they're so closely, they're almost exactly the same thing. You use the same digits, and the conversion between them is so simple. So as long as you can get to one, you can then get to the other. So obviously, if we reverse the process we just did, that would be quite easy. So if we were given fractions that were all over 100, then we would have no problem converting these fractions into percentages and decimals. So this would be 14% and 0.14. This would be 58% and 0.58. And this would be 19% and 0.19. Okay. Now the issue comes when our denominator is not 100. So if we had 5 over let's do 1 out of 5. Okay, that won't work in the same way. We can't just say that's 1%, right? Because it's out of 5, not out of 100. So one way of doing this, and this is probably the way you looked at it in primary school, is by multiplying the denominator to make it 100 so that you have an equivalent fraction with 100 on the bottom, and then you can go and do what we've been doing so far. So to make that a fraction with 100 on the bottom, I'd have to multiply everything by 20, because there are 5 20s and 100. So I'm multiplying the denominator by 20 to make it 100, which means I multiply the numerator by the same thing. So 1 times 20 is 20, so it'd be 20 over 100, which would then mean it was 20%, or 0.2. Okay, so we don't need that 0 on the end when it's a decimal. So where it gets harder is where the denominators are not factors of 100, and we can't just multiply them up by a simple number or a scale factor to change the fraction to an equivalent. So I might have 8 over 15, and my issue there is 15 is not a factor of 100. Okay, so what we have to do there is we have to remember that the line in a fraction just means divide by. So it's essentially a division. Okay, if we actually look at the division symbol, it's a fraction, right? Something over something else. It means division. That's why we write fractions like that. So this is the same as saying 8 divided by 15, which doesn't feel comfortable because 15 is a bigger number, which is why we write those as fractions. We're likely to get an awful irrational number if we do the division, but that's kind of the only way to do it. I don't actually know if this is going to give us a nice number, but we're going to do it anyway. And whatever we get, we're going to round it to 2 decimal points. Okay, so we're going to go to a decimal. So to do 8 divided by 15, I'm going to convert to my bus stop. So I'm going to put 15 on the outside and 8 inside. Now, whenever you're dividing by a bigger number than your first number, you're obviously going to get a 0 to begin with, because there are no 15s in 8. Then you put a decimal point, and our remainder is 8 itself, in front of a 0. Okay. So, how many 15s in 80? Well, there are 4 in 60, so that's 5, with a remainder of 5. There are 3 in 50 with a remainder of 5, and what will happen there is the 3s will keep going on. So actually, 8/15 is the same as 0.53 recurring. We put that little dot above to show it's a recurring number, which of course is also the same as 53.3 recurring percent. Okay. Right, I'm going to give you a couple of fractions to convert. Some of these will be factors of 100, so you can just multiply up, and some of them won't be. I'd like you to convert them first to decimals through the division, and then onto percentages by multiplying that decimal by 100. So we'll do 4 of those. So let's go down here so we can make it a bit bigger. Let's do 4 out of 19. 13 divided over 53. Some really awkward numbers. Sorry. We'll just do 3 of them because I've picked some awful numbers. 21 over 60. Okay. I'm just going to give you a few moments to try and convert those, and then I'll look at the answers with you in a moment. Okay, so I'm just going over the first one. It's actually quite a tricky division. So it could go on for a while. What I want you to do is stop when you get to 4 digits above the bus stop. So don't continue after that. Just keep what you've got, the 4 digits above the bus stop. Write down whatever that is as a percentage, and then as a decimal, or a decimal and then as a percentage. Okay, we're going to go through some of these. Some of those divisions were actually really hard. What I want to reiterate for a moment is that you if you're watching this live, then just stick with me and follow as much as you can. Remember though, if you are watching this live, then you are a member of my Patreon, so you can go back and watch this whole recording whenever you want. And if you're watching the recording, just rewind if you got confused, and look over something again. Take some time, go away to work on a couple of extra questions yourself, and then come back to it. Similarly for those on YouTube, just rewind and look at it again if you're a bit confused, and just trust yourself. You get there eventually. We will keep revisiting the revision the division as we go. That will come up in all the topics, so we'll go over it. Okay, so 4/19. I'm going to tell you what I got for this one, and I'm going to go through the division for the second one. So this one was 0.2105. It probably would have rounded to one more than that, but just those are the first 4 digits I got through the division. And then that means that the percentage is 21.05%. Right, let's quickly do this one together, so I don't rush over these divisions too much. So 13 divided by 53. Obviously, there's no 53s in 13. So my 13 is my remainder in front of my 0. Because remember, there are infinite zeros after any whole number just sitting there. Okay, so there are 2 53s in 130, which would be 106. So my remainder between 106 to 130 is 24. Okay, and these are quite big numbers, so what I tend to do is multiplications on the side. For this one, I educated guess, I thought there's probably about 4 53s in 240, because 53 is close to 50. I know that into 200 there are 4 50s. If I had another 50, it would be too big for this number. So 3 isn't going to bring it over by that much. So what I did is I did a little multiplication on the side just to test what that number was. So 53 times 4, 4 times 3 is 12, 4 times 5 is 20, add the 1, 21, 212. So my remainder between 212 and 240 was 28. I was right that it was 4 there. I'm just going to get rid of that. Well, put that in a really awkward place, didn't I? Okay, so in 28, if 4 53s are 212, probably I just need one more to fit into 280. So I'm just going to add a 53 to that. Yeah, so 265, which is close to 180, with a remainder of 15. So that would have been 5 53s. And then into 150, there's going to be 2 with some remainder, but we're going to stop there. So my answer, my first 4 digits I got are 0.2452, which means that my percentage is 24.52%. Now this next one is much nicer. I won't go through it. It was a really lovely division. Hopefully you noticed that. 0.35, nice finite number. It doesn't go on and on, which is 35%. Okay, right, now we're on to the hardest bit. This is definitely on the higher paper. So if you're doing foundation, you don't necessarily need to watch this bit, but it's always interesting to try and stretch yourself. This will be the last bit we do for the YouTube. So after this, it'll just be for the Patreon viewers when we go through those exam questions together and talk about how we approach those. So this next one is recurring or rationalizing. Ooh, I could type. I want it bigger than that so you can see it. Rationalizing recurring decimals. So we kind of touched on recurring decimals earlier when we found one. I think we had 0.53 recurring. A recurring decimal is where the same number just keeps happening for infinity in the decimal. And what we call those numbers are irrational, because to go on forever is kind of irrational. It doesn't really make sense. So to rationalize them is to make the numbers finite and to make them integers, and we do that by turning them into fractions. So that's, if I just write that down, we could probably put as a note. We do this by turning them into fractions. And we require a little bit of algebra to do this. So that might be a note worth writing down there. We do this by turning them into fractions. Okay. So let me give an example. Let's say I had the number, I'm going to do this with my pen so I can put the recurring symbol in, 0.8 recurring. Now it's quite tricky to put over a fraction of a multiple of 10 or 100 because I've got an infinite number of 8, so I'd have an infinite number of zeros underneath. So this is how we do it. What we do is we set that number as an x value. We don't have to use x. We just tend to use x in algebra. Use any number you like. It's a variable anyway, or it's a constant rather. So x is 0.8 recurring. Okay. Now what I want is a value of that, or a multiple, of that number where I also have 8 recurring after the number. So what I'm going to do is I'm going to times it by 10. So 10 lots of x is 8.8 recurring. So I've just moved the decimal point 1, right? So x and 10x have 8 recurring after the decimal point. So logically speaking, if I did 8.8 recurring, take away 0.8 recurring, I'm just taking away the 8 recurring. I end up with the number 8. Now that's the same as saying 10x minus x, which is 9x. So that means that 9x equals 8. And if we know our solving equations and our algebra notation, and hopefully most of us do, if we don't, I will be doing a video of this in the future. It's quite difficult to do this, do the GCSE kind of in order completely, because a lot of the topics touch on each other as we go, so kind of have to flip back and forth. But perhaps you might be watching this on a recording that isn't live and I might have already done an algebra video, so perhaps go to that. It'll be something like algebra formatting, notation, solving equations, something like that. Go and have a little look if you're confused. But what I do here, just to get x on its own, which is what I want, is I divide by 9. I'm going to write that like this. 8 divided by 9. 8 ninths. So 8 ninths is the answer. Okay, let's do it with a 2-digit, where one of them is recurring. So let's say I had 0.17 and 7 is recurring. Now, what is after my decimal point here, I call this x again, is not recurring. It's only the 7 that's recurring. The 1 itself isn't. So I'm going to times it by 10. So I have 1.7 recurring. But I need to times it by 10 again. So I've got 100x. So I've got another number with just 7 recurring after it. And then I'm going to do 17.7 recurring, take away 1.7 recurring, which gives me 16. And that's the same as doing 100x minus 10x, which is 90x. So 90x equals 16. X equals, divide both sides by 90. 16 over 90. Now let's simplify that. So that's 8 over 45. And that would be our final answer. So 0.17 recurring is 8 over 45. Okay, we'll do one more whether both numbers are recurring. So let's say 0.26, both recurring. So that's our x. So this time, to get this, if I did 10x here, I'd end up with 2.626 recurring. Because what I've done is I've broken the pattern in half. So I don't want that. I want to initially multiply by 100 so that the number after my decimal point is still the pattern, 26 recurring. And then I'm going to do that, take away that. So 26.26 all recurring, take away 0.26 all recurring is 26. That's the same as 100x minus x, which is 99x. So 99x equals 26. So x equals 26 over 99. And there we have it. Okay, I will go through that more in a minute when we do our exam questions, for anyone who's still confused on that and who definitely wants to get it on the higher paper. But I'm going to end the YouTube video there. So thank you very much for joining me on YouTube. Please like, comment and subscribe, and feel free to come over to the Patreon and join us there, where you can watch these lives every Sunday at 2 p.m. when they're aired. But also you can watch all the full recordings whenever you like as well, with all of the resources. Okay, so for the Patreon crowd, I'll say to the YouTube, thank you very much for joining me.